All right, welcome back. So we're gonna do one more graphing. Let's take, this is number 74. And actually it's the opposite. We're given the graph, which is really no different than what we've been doing. Okay, so we're given a graph, blah, blah. We're given, we've got a piece here, a piece here. Okay, this point here is given as -2, 0 is a vertex. And we've got a focus over here at 5, 0. Okay, so we know that it's got to be of the form x squared over 4 minus y squared over b squared equals 1. Okay, we know c. C has to be 5. So we know a squared plus b squared equals 25, or 5 squared. So plugging in, so let's put that c squared for now. Plugging in the numbers we have 4 plus b squared equals 25. So b equals plus or minus square root of 21. Okay, so our equation, x squared over 4 minus y squared over 21 equals 1. Okay? Okay, let's go back. We're going to go back and do 71 and 72. Those are a little different. Okay, 71 says, identify the conic section and sketch the graph. I'm not going to sketch it. I'm just going to identify the conic section because I want to show you guys how to do this. So we get, the equation is 4x squared plus 9y squared plus 8x minus 54y plus 49 equals 0. Okay? Okay, so now what we're going to have to do, we're going to have to put that into the form of a conic section. So what I'm going to do is basically completing the square type stuff. Okay, first thing I'm going to do, I'm going to decide, okay, let's move this 49 to the other side. So I'm going to write 4x squared. I'm going to put the 8 term together, or the x terms together. So 4x squared plus 8x plus 9y squared minus 54y. And on the other side, I'm going to put -49. Okay, so now, one of the things that I know, okay, is I know that if this thing is something that makes sense, which it will, this is going to be an ellipse. Why? Because both the term in front of the x squared and the y squared are positive. They're the same sign. So that's an ellipse, okay? The hyperbola was like x squared minus y squared, or y squared minus x squared. But when they were both plus, that's an ellipse, okay? Now, let's go ahead, let's factor out this 4 just out of these first two. Okay. I'm going to leave room for completing the square. Let's factor out that 9 out of the second two. Leave room for completing the square. Okay, so now to complete the square here, on this side, I'm going to have to add 1. So let's do that. Let's add 1. Let's put that in red here. So now if I'm going to add 1 here, what do I have to add over here? I know at least some of you said 1, but it's actually 4. Because remember, you're adding 4 times 1. Okay. Let me put that plus sign in blue. Okay. How about over here? What do I have to add? Well, I have to add half of 6 is 3. So to make that a perfect square, it's going to be 9. Let's add that in, let's put that in orange. Okay. So what do I have to add on the other side? That's right. I didn't catch it twice there. It's going to be 81 this time. Okay. So let me calculate that right-hand side. So I get 4. Let me write this as x plus 1 squared plus 9. Let me write that as y minus 3 squared equals, on this side, I get 36. So I get x plus 1 squared over 9 plus y minus 3 squared over 4 equals 1. That's dividing both sides by 36. Okay? Let me make a little more space for 72. 72 is very similar, but it's different enough that I'm going to do it. Okay? If it was exactly the same, I wouldn't do it again. I wouldn't do another problem just like it. Okay? So let's take a look at 72. 72, they give us x squared minus 4y squared plus 6x plus 12y equals 1. By the way, let me write down that last one was an ellipse. Okay, now this one, because the x squared and y squared have opposite signs, I'm knowing that I'm going to get a hyperbola. Okay, I'm going to be a little bit more careful here. Okay, and you'll see what I mean. So let's do the exact same thing. I'm going to put the x squared terms together, the y squared terms together. That one has a minus 4y squared plus 12y. Oh, they had the 1. No, there was no 1 that was equal 0 here. Okay, equals 0. Okay, now here, let's complete the square. X plus 3 squared. Let me write it this way. X squared plus 6x plus, then I'm going to factor out on that next two, those next two, I'm going to factor out a negative 4. So that's going to leave me with y squared minus 3y. Oh, man. You know why? You know why? Because my force, no? No, everything's fine. X squared minus 4y squared. For some reason, I thought I'd written it wrong. I just didn't think I'd get fractions. But that's okay. We'll deal with it. Plus equals. Now, let's do our completing the square, just like we did last time. Over here, we're going to add 9. So that means we're going to add 9. Okay. Over here, we're going to add, well, we have to take 3 divided by 2. That's 3 halves, right? 3 halves squared is 9 over 4. So that's what we're going to add over here. Now, okay, we get it. We have to add, we have to multiply that 9 over 4 by 4. So we're going to add 9 again, except, oh man, we're subtracting it. So we're going to actually subtract 9. Okay. So we're actually going to get x plus 3 squared minus 4, y minus 3 halves squared equals 0, which I didn't expect that. The 0 means that's not actually an ellipse. That's what we call a cone. Or not a hyperbola. It's what we call a cone. But not important, really. Same sort of idea. The thing is, I wanted to practice showing you what happens when you do completing the square for hyperbolas and ellipses. Okay? Or cones. Okay. All right. I'll see y'all in the last video, which is an applied problem.